Well, I rise every morning at 7:45. Some woman who's my wife says, now don't be late. The kids say goodbye, I can't remember their names. Week after week, it's always the same. And it's a, hey boy, can you code it? I can program it right. Nothing ever happens in this life of mine. Hauling out the data on the Xerox line.
Hello, everybody. Welcome to the Greater Boston Drupal Self-Help Group. We meet every other Thursday, and our meetings are announced on Drupal.org in the Boston subgroup. Tonight, we have a presentation on Git. It's going to be presented by Rick Umali, and Rick has been a programmer since about 1991, so he's been at it for a while. Just to give you a little perspective, 1991 was about the time that Linus Torvalds decided that he ought to plug the hole that the GNU project had left and write a kernel. So, you know, Rick's been around for a while. He is now a web developer and a Drupal enthusiast. Welcome, Rick, and I'm sure it'll be a great presentation.
Okay, thank you very much, Mark. As I get oriented to the screen here. Okay, again, thank you, Mark, for that great introduction. My name is Rick Umali, and there's my email, and there is my website. It's a technical blog. The slides that I am presenting from are on Google Docs at that short URL, so you can follow along if you're connected to our wireless network here. Inside of the Google Docs are the notes that I have researched and looked at for this presentation. So there's a lot of resources out there for Git. If you want to see the bits that I use to begin this presentation, they're in the speaker notes. I think a few more things to say in terms of housekeeping. I looked at this presentation and I've gone over it a handful of times. It's about an hour, and because of that, we probably will want to table our questions or write them down as you think of them, and then we'll have questions maybe afterwards. But other than that, we're going to try to get through a live demonstration of Git, try to get through a demonstration of its power and its efficiency and what it's used for, and also really why we want to try to start using it. I'm going to talk about source control. I'm going to talk about why Git is such a big deal. And I'm going to give you a little bit of Git by actually logging into my computer and showing you some of the Git commands in action. So I know I know the audience watching may not have a quick view, but how many people here do use some kind of source control? Okay, about 80% of you have raised your hands. That's good. And of you, how many of you have actually used Git? Okay, good. A smaller percentage, not by much, but you guys can keep me honest as I'm going through. You'll be able to mark me at the end and say, you know what, I don't think that Git ad was quite right. But for the rest of you, and for all of you who are watching this later, we're going to take a look at Git, what is today considered by many to be one of the most modern source control systems out there. Source control. I think I'm just going to jump to this last point here. I think if you want to consider yourself a professional, if you want to give people the impression that you're a professional developer of any kind, whether you're developing CSS, HTML, you really need to use some kind of source control. I feel it's the most important practice a coding professional can do, and I get that feeling because every time I start a new job, and I actually started a new job 2 months ago, the very first thing that the orientation will take me to is our source code depot. We're going to say, oh, Rick, here's what our source code tree looks like. Here's how you can check out the code. Source control is very important because it allows developers to be able to look at their changes happening as they're happening, and also to go back and look at those changes as a record of things that have happened. It's a means of version history, it's a means of auditing, and it's also, quite frankly, it's a means of recovery. Sometimes you might be playing with open source projects, or you might even be playing with commercial projects, and they'll say that, oh, we need to issue you a hotfix, or we need to issue you a build that addresses a particular problem. Well, those builds and those hotfixes come from somebody in source control going backwards in time and making a fix to a particular branch. Now, some of that terminology may not be familiar, so we're going to go and introduce some of that now. But again, I can't emphasize it enough. It's the most important thing as a coding professional. That's the most important thing you can do. This is the slide that I would show if my mom and dad asked me what source control was. Now, they know I'm a programmer, but I couldn't show them something on my screen that would really make sense to them, but they both have been to Wiki. And if you look carefully at Wiki, what you'll see on the tab of every Wiki entry is a history tab. When you go to that history tab, you will see basically a screen that looks like this. And this is the Wiki revision history for the revision control entry in Wikipedia. So it's a little, unfortunately, it's a little self-referential. I should have picked like Britney Spears or something. But you can see that this Wiki page has changes from a gentleman named Mitch Ames back in April 22. But you can see that maybe 39 minutes ago was another change, maybe by this gentleman named Jarbel. We don't know, it's just an IP address. But what you can see is a record of changes on this web page. And apparently there's a lot of tools out there that process this record, this history. But the importance of this is that people can always look at this and get at how the web page, how the wiki entry got to be where it's at. And in fact, that's all that software is in reality. It's a artifact by programmers, and to figure out how it got to you, you can look at the revision history. So this is the revision history on Wiki, and it is what I would, like I said, show my parents, show my brothers what version control is. Now, unfortunately, I wouldn't be able to show them this. I mean, I could show them this, but this is what we're going to try to do tonight. We're going to try to we're going to try to understand this screen by the end of the evening. We're going to actually create a Drupal module right in front of your eyes. I'm going to track my changes using Git, and we're going to experiment and use Git during that entire process. Again, we're going to be here for a little about an hour, but during that live demo, we're going to see us building out this revision history, and you'll actually understand what this history is. And as a bonus, you'll be able to download this entire history because Git facilitates repositories being stored on the internet. There is an internet location. It's called GitHub, where you can download this code and actually have this history running on your own computer. So this is what we'll be doing tonight. So what is Git? You know what, it's unfortunate that I don't have the inventor of Git on here. The inventor of Git is Linus Torvalds, the gentleman who invented Linux. Linus, now, as people here know, Linux is a monstrous open source project that implements the Unix kernel. It was sent out into the world in the early 2000s. For a very long time, Linus used a commercial software to keep track of his source code changes. But it's kind of ironic because Linux is open source, but they're using a commercial piece of software to do it. So there was some uprising and there was some hand-wringing. So Linus said, well, I'm going to have to break free from BitKeeper, so I'm just going to have to write my own. And he did. He wrote this thing called Git. This paragraph is directly from another presentation, which is in the show notes, by Scott Chacon, who wrote the book that I referenced for Git, which is Pro Git by Apress. And it's an open source distributed version, etc. What you see here on the screen. But what does that give you? What does this first paragraph give you? Well, Git gives you certain freedoms from cost, first of all, but it also gives you certain freedoms in terms of it's open source, so you can look at the code, you can inspect and audit what the creators have done. The fact that Git is distributed means that there's no server required. Distributed kind of suggests that Git is out there on the internet in different places. What distributed offers is a way for developers to do source control locally and distribute their changes as complete units. And we're going to show you that in this presentation. But the key is that there is no server required. In every version control system that I was shown as I progressed in my career, they were almost always server-based. CVS, ClearCase, SVN. Today in my work I use Perforce. They're all server-based. You need to be at your computer and connected to a source code server. With Git, you do not need that. With Git, you just start using it. And finally, there's a unique architecture to Git, which makes it very fast and very efficient. This presentation won't go into that because I would need a lot of diagrams. It would be, quite frankly, I like to think of Git as a bunch of black magic, and it might be the best way to think of it, especially if you're starting out with using it. But I will touch on some of the unique bits of the architecture as we get going. The installation of Git, for those of you who have not installed it, is very easy. If you go to this URL, you'll find easy steps for your Apple, for your Dell, for your IBM, or for your PC compatible that's running Unix. It's extremely easy to install, and I'm going to leave it to this guide to do that. We're not going to install Git. I'm going to warn you, though, that in the demonstration, we are going to look at some of the command line. Now, Git was born and bred by people who lived and worked in the command line itself. I'm going to be typing in commands to a terminal window. I hope that doesn't throw you off too much, but it is something that you may need to get used to when you work with Git. It is a command line tool. There are graphical user interfaces for Git that make it slightly easier to understand, and I will be leaning on that throughout this demo, but it's primarily a command line tool. So let me show you some Git right now. The first thing you need to do is let's say you've installed Git. You don't have to start it. You don't have to tell Git, go ahead and run. What you have to do is just tell Git who you are. And I'm going to switch over to my screen and show you that I've already done that. I have told Git my username, I have told Git my email, and I've told Git a few other settings, and we're going to get into those later. I include this slide because every tutorial of Git includes this slide. I feel like I'm going to jinx the whole thing if I don't include this slide where you tell Git your name and your email. Where it will be used is when you make your changes to the repository, this email and this username will be recorded with it. Now, throughout the slide, there are going to be all these notes like, here's Git config help. Please feel free to read them. I may not go through it in this talk. The key is Git is very friendly. To me, it's very friendly. It's on the command line and whatnot, so it's as friendly as a command line utility can be. But it is helpful. It does give you suggestions, so pay attention to those as well as what you see on the screen here. So let's just get right to it. We're going to create a Drupal module, and I'm going to follow these steps here right on my computer screen. So lo and behold, I'm in the right directory. And what I'm going to do is create a module. Let me start my browser. And I'm going to create a module that when we use it, it will display a timestamp. Oh, Chromium didn't shut down properly. It's okay, Chromium. I understand. Okay, so we're going to create a module that is called dump stamp, for lack of a better word, provided my Drupal actually starts up. While that's going, I am going to create the first parts of this, which I've already done. And I am going to make sure that my server is up. And if this doesn't work, then well, we'll have to go to plan B. DGD. Okay, here we go. It's just that tab. Yeah, okay, good. We got to the same place. We're going to make a module that when you type in this URL, it will actually do something. It'll display something to the screen. So I've created a directory. I am going into the directory. The directory is empty. And what I'm going to do is what am I going to do? I am going to initialize the Git repository by typing in the command git init. Now, right here is the power of Git, because I didn't have to talk to an administrator to set this up. I didn't have to do anything crazy with a configuration file. All I did was just ask Git, initialize a repository in this directory. What Git will do from now on is it will track everything that happens in this directory. And git init, just so that you see a little bit of the details, the directory is empty, but it actually creates a hidden directory. If I go into it, it contains all of these files. I'm not gonna get into all of these files, just so that you know there's not a lot of magic going on, but there is a significant amount, but it's hidden, it's behind the scenes. When you initialize your Git repository, you have in effect created a source code repository. And just so that I don't lose anyone with the word repository, think of a repository as a database. It's a database for your code that you're creating, whether your code is CSS or HTML, or in our case, PHP code for Drupal. It is a source code database, but the convention in the industry is to call it a repository. So we've just created a repository, no server interaction required. We're going to now commit our first file. Now, the vocabulary of using a source code control system often includes the notion of submitting and committing, but quite simply, it just means that you create a file and you want to tell the source code control system that, hey, there's a new file here, please store it. And it's too bad it's not named that way, but let me go and create a file, readme. This is a readme text file for my module. I've created a file. Now I'm going to tell Git, please add this file. I'm going to tell it, add this file. And then I'm going to tell Git to please commit this file. Please properly store it into the directory, into its repository, excuse me. First module, first commit, a readme. I'm a big fan of the exclamation point. And it throws me. Okay, so git commit -m. Okay, so what did I just do here? I've created a README file. This README file is inside of my directory that I've identified. So now I've asked it, please go ahead and store it into the repository. And when it does that, it actually puts it into its source code database in a way that later on we could go look at it. Let's take a look at it right now, what it looks like right now. So if I say git log, what it'll show me is a record that I have committed this file. It's a file, it's my README, and it keeps every record with an ID, and of course the username and password that we entered earlier, and the note that I gave it, which is first commit, a README. Now I'm going to start another tool called gitk. This just happens to be the tool that runs in Linux, and I'm going to bump up the resolution just a bit. Data sans. And what you see here is again the very first entry in my repository, which is the first commit. It's a README. I'm not going to get into all that's going on in this screen, but this is another way to think of the repository. When I first started doing source code control, when I first graduated from school and Chris Peterson was showing me source code control, one of the things that struck me was that it's basically like a diary for your code. You're writing code and it's like a diary entry, like, oh, I just made a README file. The mental model that you should have is that of a diary or a record or a log of some kind. That's what source control systems offer you, is a way to keep track. It's a way to record your code changes. So I know we're going slow here at the start, but we're going to start picking it up. We're going to add a few more files. Namely, we're going to add the files that we need to for the module itself. Namely, for Drupal, we need an info file and we need a module file. Now, I know this isn't about creating a Drupal module, but as bonus content, these are the two files, the only two files you need to create a Drupal module. You need a file that tells you what the model is, what the module is, and then you need some PHP to actually do the work. And this is saying that whenever I type in /dumpstamp, please print the word dumpstamp. And in fact, well, I'm going to show you this running in a quick second, but let me tell Git that I've done something. Or better yet, let me ask Git, have I done something? I can ask Git, what's the status of my tree? What's the status of my directory? And Git tells me that there are two files that are in the system, but that are untracked. So what I'm going to do is I'm going to add these files using this shorthand, git add, and then I'm going to commit these files. And if I type commit without the switch to add the comment, I get put into this editor. It's a little hard to read, but I'm just going to say this is, these are the files for my Drupal module. And now it's added these two files. And what I want to show you next is what the repository looks like. But first, let's go into a little bit more of this Drupal thing. We can tell Drush right away that there's a new module here, Drush PM info dumpstamp. And when I do that, it tells me that, hey, you have a module that's called dumpstamp. It's not installed, so I'm going to enable it. And when I do, I can go. It wants to know if I actually want to do this, so I say yes. And when I go to this URL after I've installed it, it will now print, should now print a message to us. And there it is. So there's a Drupal module right before your very eyes, two small files, a little bit of knowledge with the hook, with the menu hook, but we're mostly about Git today. So what we've done is we've added a README file, we've added two source code files, and I'm going to ask Git, tell me what's going on. Nope, everything is good here. When you go to the tool and refresh it, you can see that there's another entry in our diary of code writing. That here are my files for the Drupal module. You can see that in this little experiment that we're doing, we've just done two things. We've added a README and we've added two files, and we've been faithful about tracking all of this in our source code control system. So let me go and make another change. Now I'm going to do this twice more, so I'm going to speed this part up. Let's say I want to make a change to this. I'm going to try doing this a slightly different way. All I've done now is I've replaced the method that prints the word dumpstamp with a more sophisticated looking method. It uses a Drupal render array. But again, all I've done is just make a code change. And when I refresh my page, you'll see that now it's saying something different, dumpstamp in a variable. And now I can ask Git, so is there anything new going on? And it will say, hey, you've modified a file. So let me go ahead and commit this. using variables. And so you get the picture. You make changes to your directory, which Git is tracking, and you tell Git that, hey, I've made a change, and you commit it. I'm going to do it one more time. I'm going to say, I'm going to make a change to this. I'm going to make a slightly bigger change. I think it's 3 I'm up to. And this time I'm going to use a bigger change, namely, I'm now going to make the module react if I type in a username after this URL. If I type in Rick, I want the module to display the name that's on that URL. So I've modified the code to do that. And when I commit that change, now you can see when I type in /Rick, I actually get Rick displayed in the message. So I've made another PHP change. Now I'm going to tell Git that I've done that. Git status, fine. I can actually tell Git, tell me what is the difference. I can ask Git, please tell me what is the difference between those two files, those two things that I've just done. And you'll have to read later how to read this output, but this is quite literally saying what is different. And this user tool actually shows you what those differences are in a slightly better way. It shows in green the new things that I've added. It shows in red the things that I've deleted. So again, Git is not only tracking changes in the files, but it also tracks which exact changes in the file. So I'm going to commit this change, and I'm going to give it a message. Now using a variable. Nope, now using a URL. Now reacting to you. Okay. And now when I look at my history, I have here now reacting to URL, and I can look at the log, and it now shows all the 4 things that we've done. And just to, again, keep harping on it, because it's a mental model that you have to have in your mind. You created an empty directory, you've added a README file to it, you've added 2 more files to it, then you've made 2 changes to one of those files. And because you have asked Git to track them at all times, Git is faithfully recording them. And with that, you now have a repository that kind of looks a little bit like what you might use like if you're doing an individual project. So again, this is the typical workflow. We've already taken a look at the log, but I want to show you one more output. When you say git log, it shows it to you in a kind of a big listing. It's a little bit bigger than the screen I have here. So you can ask Git, please show me a short and sweet version of what's been happening. And here you can see that we have a log where everything is on one line, and all of the identifiers have been shortened because they're still unique between the 4 that we have here. But I know these are just details. The slides are meant for you to take a look at afterwards and digest and to try on your own. The key thing is the mental model. The key thing is that we have created an empty directory, and we started to make changes in that directory. We've added files, we've modified files, and every time we've made a significant kind of change, we've asked Git, please record this in the repository. And that's really the mental model that you need to have when you're doing development with source code control. And quite frankly, it is the work, I guess, is the modus operandi of most developers. If you are a software engineer, if you are a programmer, if you're doing any kind of code, you often think in those terms, like I'm making an HTML page, I've added a menu, that's a commit. I've added a footer, that's a commit. So again, we've established that Git can track all of these things. And now that we have Git, one of its most important features is you can always go back. Now that you've kept a track of everything, you can always go back. So if I wanted to go back to say the first entry, Git checkout. Now I'm going to do something, and Git is going to make some noise here, but if I ask Git, please get my directory into what it used to look like, It's going to make some noise about that I'm in a detached head state. Don't worry about that. I'm just going to show you with a directory listing that there's only the README file in there. Now remember, I had 2 files in there for my Drupal module, but when I asked Git to check out a code from an earlier point in my work, Git will say, okay, I'm going to give you back that code, whether it involves deleting files or changing files. You can ask Git, and here it just shows that there's only 1 entry. To go back, you can tell Git, please check out the master, which is the code at the very top of your basically it's your latest changes. So now if you do 1 line again, all your files will be there. So the revisiting history is a critical piece in developing software. Many times you will need to be able to go back in your history. More often than not, it's when the client says, hey, something has happened back in some code that you delivered to me about a week ago. You need to be able to go back to that exact spot. And with Git, you can do that. Now, I'm going to go into a harder mental model, but I'm going to first, let me first express that everything that we've done up to now, in say the past 20 minutes, is I feel everything that you really need to know about Git. To just use it on a regular basis, you need to know how to add commit, you need to know how to ask Git what its status is, you need to know how to ask Git what its differences are, and you need to be able to ask Git what's in you with Git log. Those are the only things that you need to know in using Git for an individual project. What I'm going to show you next is what I feel is like the last 20 to 30% of Git, which is branching and merging. And I'm going to demonstrate this, but the mental model I want to introduce is the notion of a branch, and what is a branch, and why, more importantly, why would you even use it? Just by show of hands, how many people here have ever been to a farm and you go to those displays where they have like this huge giant maze made of shrubbery and hedges? Has anybody ever done that, where they go to a farm? It's basically a human maze. You're inside of a human maze. Okay, that's great. I've never done it, but the thing is, I'd probably be scared to do it. But the thing with a human maze is, or with any maze, is that you're going to be at a fork in the road. You're going to have to make a decision of going left or right. Frankly, you probably have to make a decision beyond left and right. But to keep it simple, you're in front of a wall and you say, you know what, it's either a left turn or a right turn. I got to make a left turn. What if you could, well, more importantly, in that maze there on the farm, you want to be able to retrace your steps if you make a mistake and you realize, I'm not going to get out this way. So you go back. When you took that left turn and it didn't pan out, that actually is a branch. A branch to me is a fork in the road, where you are looking at something and you say, you know what, I can go this way with it, and I'm going to go down that way for a little bit, but if it doesn't work out, then I'm going to go back. And that's what a branch is. It's a way to say, I'm going to try something new here, but I always have the ability to go back to a starting point. That's the mental model to keep with regards to branching. Now, it's a command line tool, so it's a little hard to get the excitement of it. So let me just show you a picture. This is what our repository looked like one change ago. Now I made a change and I've committed it, and now I have this new change up here in this block. So just pretend that each of these squares is a change that I've made. Now I realize that there's a way I can do something different back here in SHA A1, in SHA 1A, pardon me. So what I do is I ask Git, hey Git, please make a branch down here. I want to try something new, but I don't want to forget about SHA 2B. So I tell Git check out -b branch 1 SHA A. It's no good saying command line stuff out loud, but I'm going to type it soon for us so we can try it ourselves. But when you create a branch, what you're doing is you're creating a pointer back to some spot. Again, in the mental model, there in the maze on the farm, you are here on the left, and you say, you know what, I'm going to go back to SHA 1A. And then you go down that right path. And you make some changes, you commit them, and you think, yeah, okay, it looks good. I like this path. But now your source code repository, your Git repository, has a fork in the code. You have SHA-1A, but now you have these two divergent streams, and your repository has kept track of it all. Now I'm going to do all that right now. I'm going to say git checkout -b. It doesn't look sexy, but what I'm going to do is I'm going to go back to when I said using variables, this one. I'm going to make a branch that's called adding a timestamp. Adding a timestamp. One of the beauties of Git is that you can name these branches anything you want. So I am now adding a timestamp, and if you look at the code, actually if I refresh the code, this RIC will no longer work. It's back to a piece of code that I was at before. Now I'm going to edit my code, and I'm going to drop in some new stuff, specifically some code that I've already pre-wrote before. Here's a timestamp, and if I like it, if it works, and I refresh this page, now I have a Drupal module that prints the time when I made that change. So I went back in time, and I made a new change, and now my repository has a fork in it. Basically, it looks like this. Now, you can ask Git using this command line down here. I'm not going to even try to type that in. I have an alias for it, which is what you saw earlier. Now you can see that my URL has these changes in it. I'm adding a timestamp. I'm using variables. Actually, I just realized this. I didn't save the change. It doesn't look like what I had in the thing. So let me go and commit. Adding a timestamp. And now if I do that command, again, just try to keep that maize in the farm image, because when I try to show you that that's what Git's telling us, that it is true. Right here is that fork in the road, and Git has said, hey, there's some code up here, and there's also some code up here, and they all originate from a single point, this part where I said using variables. So that's what a branch is. It feels advanced because it is. I've been working here's where I say, I've been working in computers for 20 years and I've never done a branch before, except you just saw me do one now. But my point is, as a professional, working for software companies, I myself have not done any software branches or later on we're going to do software merges. And the reason why is that source code control systems are notoriously difficult for doing branches and merges. If you use a tool like Perforce or SVN, those tools require an administrator to create a branch using some equivalent SVN copy, Perforce integrate. These commands are nothing like the commands that you have in Git, where you just say, please branch me from here. It's a little more, it's more arduous to do branching, I feel, with other software systems. Whereas when I started to look at Git branching, I realized, wow, this is actually pretty straightforward. You can do the branching and make a source code tree that looks like this, source code repository that looks like this, very easily in Git. Now we're kind of in a pickle here, because quite frankly, I like that functionality of whenever I type in my name, I get to see it here in my web page, but I also like this timestamp. What I want to do now is merge the code together. Now, what you do is you just follow this slide here. You basically say, please Git, you want to say, Git, I want to merge these two source code files together. Now, I mean, Git is much more powerful than just doing simple files like what we're doing here. Git can merge and branch entire directories and entire subdirectories. But for our purposes, we have this picture today, right now. What we're going to do is we're going to just tell Git, go to the master and merge in branch 1. And it will do that for us. And when it does it, you actually get into a kind of a funky, hard part here. And this is, the whole time I was preparing for this talk, I thought, I don't know if I want to show people this, but it's very colorful. And what it's showing us is that Git realizes that there is a single file in which there are changes that a human has to look at. Now, by default, Git is going to always merge automatically as best as it can. I mean, it's got the creator of Linux writing it, so I imagine he's got some cool algorithms up his sleeve for doing automatic merging. But what we're doing here, what Git defers to a human, is whenever there's a single line that's been changed in the same place in the two branches. So if I go back to my slides, I have code in 2B and 3C, but they are in the same single line. And Git won't touch that. Git may try to touch it, maybe I have an older version, but in a case where Git says, you know what, I can't resolve this, a human has to do this, you'll have to do a manual merge. And as I'm talking to you now, it just feels like this is an ideal situation. This is probably merging in the worst light, because again, this is something that you have to get involved and do something, but Git really will try to do this automatically on its own. So let's just do that together. I'm going to go check out the master. I'm here in this code, and I'm just going to try to do this like this. My repository says that I'm in the branch adding a timestamp. So now I'm going to say git checkout master. And you can see Git has said, okay, now I'm in the master branch. And this output, the repository says, now you're doing work on the master. And now what I'm going to say is git merge, adding a timestamp. And in fact, this is where Git will actually complain. Here Git is saying, there's a conflict here, you need to go and take care of this. And then if you take a look at your code, it actually will contain, it's a little hard to read, so let me try to show you this here. On line 20 down to line 32, Git has identified the lines of code that it's having trouble with. And it says, oh, I'm having trouble up here and here, so could you figure it out? The tool that I used in the slide looks like this, git merge tool. And I'm going to press return. It's a tool that does it for me graphically. And you can see that you can see the conflict that Git is having. Git probably doesn't have a problem with this change, but Git definitely has a problem with this change. The fact that I have this variable Rick, but I don't have it in this part. Git likes this dump stamp, but then I have a timestamp here. It's probably okay. Basically, you can see that this merging is kind of a manual operation. What I'm going to do is, because I've already pre-written the code, I'm going to just manually merge it myself. I'm going to say git dump stamp module, and I am now going to bring in what the merge code would look like. Although in practice, if I were doing this, say at work, it would probably be like an hour or two as I figure out what is the actual difference. When I reload the page, what we should see is both my name, and what we do see is both my name and the date together at last. And what I'm going to do now is commit this change. Did the manual merge. This is the commit message that we will see in the log itself, here at the very top. And I think if I did this right, what you'll see is a branch that you kind of, you have to squint to see this, so please take your time when you get back home to take a look at this. You can see that back here is where I did that fork. There I am in the farm. I decided to go left, but then I also went right, and I did some stuff when I went right, but now here I am bringing the two together. And that's what merging is. Very quickly, Git lets you do that visualization on the command line as best as it can on the command line. So we have, again, you have to squint, but here I made a change. I went down a fork in the road, and then I went down another fork. So you can see that there's a merge happening here, and Git can also display that output on the command line. like I said, I almost did not want to talk about branching and merging because it is a topic that I myself have not really done as a professional. The reason why, again, is that usually there are other professionals that work on computers that do this. People, they have titles like integration engineer or release engineer. The people who keep the branch, especially in big companies, there could be a group of people that just manage the source code tree. This picture is from a really nice white paper, a really nice paper that talks about patterns in software change systems. And this is, I love this picture because this is what a software project looks like. If you, any commercial software project you have, I promise you that there is a whiteboard with this exact same diagram on it because I know the people that do that stuff. I'm a person that gives stuff to main, but then somebody has to go and make the maintenance release. Somebody has to go and make the bug fix release. Sometimes it's me. But the key is that I'm only committing my code to one place, and an expert is making the branch and the merge. But with Git, you are the expert. You have the ability to make those changes. You have the ability to branch on your own repository and make your own merges work. Okay, so that was branching and merging, and please keep in mind that the only thing you need to worry about is git init, git add, git commit, git log, git stat. Those, just keeping track of your work is the workhorse piece of Git. The branching and merging is something that I feel is a 20 or 30% is a 20 or 30% situation. But I think it's great to have it be demonstrated. I think it's great to try to offer some model for it because it is arcane. And in reality, that is what it looks like there on the screen. So very briefly, in the remaining time, I am going to talk now about this concept of remote branches. You have this repository. I have this piece of code here in my picture here. I have this block of code. And what I'd like to do is share it with other people. And in fact, it's very easy to do that. You can put it on a thumb drive for starters. But you can also use some sophisticated Git functionality to push this code to a public repository. And conversely, you can browse public repositories for interesting code that might be, that you may want to use or that you may want to examine. Here are some very common public repositories, GitHub being the first one. I've used these first three. I have not used Bitbucket or the repo one. But basically, you can take your repository and upload it someplace to share it. And conversely, you can go to a public repository, browse around for code, and download it for yourself, like we're going to do in this slide. On my GitHub, I have three pieces of code. One is this Drupal module that I just created. One is source code to a version of Tetris that I wrote, and then one is my vanity website, which I wrote in Perl. If you wanted to look at that code today, you could go and basically do that clone command that I have on the slide. And when you do that clone command, what it does is it goes to GitHub using a public user, if the internet is up, and we can pretend that the internet is up, but it will go out to the internet and download the code for me. And I'm in fact going to just check to see if GitHub is up and running here. Okay, maybe I've disconnected. But the key is that you can go ahead and go to a tree and grab the code and take a look at it. It's really powerful because chances are you will want to do something that somebody else has done. And if they are doing open source, if they embrace that model, then they probably have a public repository that you can go and browse the code from. If you wanted to upload your code, say you wanted to take your code and put it up to GitHub, what you do is you do these 4 steps. Let me just go through it in the slides. You first create a key pair. I'm not going to get into this. These steps are actually very well documented on GitHub. But you create a key pair. I'm using a Unix tool to do that, but you can use other tools. You import that key pair, and then you create an empty repository. And then after you've created that empty repository, you push that code all the way up to GitHub. And this is what it looks like on the screen. Okay. Yeah, the web page not available, but let me see if Google is available. Okay, so it's something else here in the network, but after you upload your file to Git, your repository actually tracks that you've pushed it out somewhere. It creates another, for lack of a better word, it creates another label. In the parlance, it's actually another branch called your remote branch, which has master, but is associated with this origin. But that's all like a technical detail. The key is that your repository has kept track of the fact that you're someplace else as well. And that actually introduces many more complex topics about Git, namely pulling and pushing and doing those kinds of operations, Git fetch, etc. But we're going to stop here. I'm going to encourage all of you to go ahead and get Git. It's hard not to say get Git. I thought I could avoid it. I couldn't. Install Git on your computer. Give it a try. Take a look at these steps that I have. You don't even do the branching and merging. Just go ahead and just keep track of a directory, even if it's just text files. I'm going to ask you then to try to commit your code changes frequently. You're comfortable with Git. Go ahead and track like a website. Just go into the directory of your website, say git init, you're already tracking things, git add, push all your files into the repository, git commit, and then as you make changes, commit them and commit them frequently. And really as like extra credit, I would recommend logging verbosely. I would recommend go ahead and say as much as you want in these log messages. These log messages, even though they're like one line here, in repositories that I've had the pleasure to look at, these can be whole paragraphs of somebody's record of why a change was made. And finally, experiment and branch often. I think prior to learning about branching with Git, if I wanted to experiment with a piece of code, I'd probably just make a copy of that directory and do my work someplace else, untracked, which is kind of unsafe. So with Git, it provides you a safety net with experimentation, namely branches. I just want to say a few words about the resources before I go. I really recommend Pro Git. It's a book you can buy, but it's also a book that you can just look at on the internet. Its entire contents is up on gitscm.org. I really like this walkthrough of Git magic. I have this, it's a local copy. I like the layout. It's got a nice thing here, basic tricks, cloning around. It's light and it kind of gets into more detail of what I've done. I recommend getting that. You can also just use Git to grab the entire set of HTML files. One thing that I didn't cover in this talk is how you might use Git in the context of Drupal. We use Git in the context of a Drupal module, but it turns out because Git has these capabilities for pushing and pulling files, you can actually do a lot with Git for your entire Drupal installation. And I recommend people to take a look at that. I'm digesting all of that stuff that's in here. It might be the basis for a separate talk, perhaps. Finally, here's something where Linus talks about clean history. Again, he talks about the log that you would keep and why you want to keep it clean. Finally, the last slide here, the next to last slide here, the last slide looks like this, but the next to last slide is resources. On YouTube are 3 great videos about Git that are really deep, i.e. they're each over an hour, but the Linus Torvalds talk that he gave to Google in 2007 is about as, I don't know, saying that, Moses with the 10 commandments on the tablets. It's not quite like that, but the point is Linus was in a public audience. He doesn't like to speak publicly, and he's basically giving his rationale for why he had to create Git. It's a very interesting topic. He's also a very interesting speaker. He's got a pretty wry sense of humor. Randall Schwartz, I'm a big fan of Randall because he's a Perl guy. but he apparently met Linus back in 2005 when Linus was inventing Git. It's a great video because he gets into a little bit of what I got into, which is how you would use Git on a day-to-day basis. But I really recommend, out of these three, I really recommend Scott's video because he is the author of a book about Git. He is a renowned expert in Git. He's the CIO of GitHub, and as a result, he knows what he's talking about. And his pictures are wonderful. Mental models, like I just said about the fork in the road, he's got those in abundance in his presentation. Diagrams that are a little more accurate in terms of the details underneath Git. So, getting started with Git, I hope everyone is not too scared off with the branches and merges. Really, the big part of it is committing your work frequently and having Git track your work. It becomes very important because you can go back in time and figure out things when you need to go back. When your client says, "Hey, something you gave me last week is not working." Uh-oh, I'm running low on power. I'm at the end. So again, thank you everybody for hearing me on getting started with Git.
Someday I'm gonna give up all the buttons and things. Punch the old time clock until it can't ring. I'll burn up my necktie and set myself free. And no one's gonna fold, bend, or mutilate me. Hey boy, can you code it? I can program it right. Nothing ever happens in this life of mine. Hauling out the data on the Xerox line.